with everything we're doing in Chapter 6, everything in the first two sections we did last time, we did 6.1 and 6.2 were factoring. The big thing we did back in 6.2, and this part, again, we'll just go back and do a quick review, was if we were factoring something like this. We had x squared minus 4x minus 12. The big thing we were doing is that if you go back and kind of look at the different parts here, a value was 1, b value was negative 4, and your c value would have been negative 12. And the whole thing we were keen on last time was if it was just a regular trinomial, we weren't doing greatest common factor or anything along those lines. The whole thing we were doing was we were looking for the factors of negative 12 that would have a sum that was going to equal the b term, which would have been negative 4. Okay, so if you list your factors, 1 and 12, 2 and 6, 3 and 4. The sign of the b term always goes with the bigger factor. So if you're doing 1 times 12, that's going to be negative, that would be negative, that would be negative. To get the sign of the other factor, you would just divide these two numbers. Negative by negative means that positive. And then once you found the pair that added up to be negative 4, all we were going to do was take those two numbers and put x, or whatever variable we had, in front, multiply it out, and we had it back. Okay, so that's what we were working on last time. We did greatest common factor, where you just take out whatever the greatest common factor was. We also did factor by grouping. And everything in sections 1 and 2 was building up to what we got to do in section 3. That for this one, the shortcut was in 6.2, was that the a value was always going to equal 1. It gave us a shortcut. We could do a very quick factoring. Good to go. Everything was there. 6.3, we're still factoring trinomials. But the big difference in 6.3 is that we go from the first term being 1 to the first term being something other than 1. So we'll say that it's trinomial, but it's also quadratic. That again, it's ax squared plus bx plus c, where the a value is not equal to 1. And again, when we talk about a quadratic, that's ax squared plus bx plus c. Okay, now there's two, well, I guess there's one main way that you can do this, and then once we kind of get through the first step, everybody's got their different way that they do this one. And I'll show you a couple different ways, and you can kind of figure out which one that you like, because this is something that's changed over the last really 15 years or so, that this has kind of come in to get what you have to do for this. But here's the idea, and we'll give you an example. First off, we'll start with everything positive, and we'll go through all the steps on this for what you want to do. Well, actually, I'm going to go ahead and give you the steps before we do that. Okay, the very first thing you're going to do is you're going to multiply a times c. And technically, if we go back here with this problem, we would do the same thing, but multiplying 1 times, you know, the a value is always 1, so when you did 1 times negative 12, it was always just the number, so we didn't really have to worry about this one. So for this one, we're going to do the same thing. We're still going to do a times c over this part. Step 2, on the same lines, you're going to find the factors of whatever this a times c value is. Whose sum is equal to b. So that part's going to be the same. Still looking for the factors of this number that's going to equal the b term. Now, the difference is, for step 3, we don't get to just, once you find the factors, how we had the paragraph, had the parentheses, we were done. This one, this is where everybody does something different past step 2, that everybody step 3, depending on who taught it to you, everybody does a little something different. I'm going to show you what what I do, and I'll also show you a different way you can go for this one. Step 3, I would say go ahead and list out the factors. So that for this part, we'll go ahead and do just like we were doing before, that we're going to take, if the factors were 2 and 4 like we had in the last, or 2 and 6 like it was in the last problem, we'll go ahead and write 2 and 6. Okay, here's where it's going to go extra. Here's the step 4 that's the extra part. Because we multiplied by a in the beginning, now the numbers are basically kind of too big. So what we're going to do then is we're going to go back and divide each factor by the a term. Or we'll say we're going to divide each factor by the a value. Okay. And because you're dividing and now you've basically got a fraction, you'll go ahead and simplify whatever numbers are that you have in the fraction. So we'll say simplify each fraction. Okay, and then we'll say this: if a fraction cannot be simplified, because if let's say we'll look at one of these numbers and let's say we've got 1/2 as one of the fractions. Well, all the factoring we did, it always comes out to be just these regular factors that we're doing. So if you want to go back and fix this thing so we get just regular factors and there's no fractions in this part, if this fraction cannot be simplified, some people call this the bottoms up method, because you're going to pull the bottom number up in front of x. And depending on where you go from, some people call this the bottoms up method, because you pull the bottom number up in front of x, and then the fractions are gone, and now you've got this nice group of whole numbers that you're looking at. Okay. Now, some people, and I'll show you this one, and show you what we can do. Some people, when they, after the first 2 steps, because everybody pretty much does the first 2 steps the same. It's after that, when you get to step 3, what everybody does and how they do this one. Now, the way online, probably the way Alex is going to show you for this one. So we'll kind of say this is the Alex version. So if you're walking through some of the examples and they show you what they're going to do, you can kind of see this one. It works similar, but it's just a different setup of how you want to look at it here. So step 3 says, all right, you found these different factors that you've got. For the Alex version that they're going to do, they're going to tell you to replace the b term with the 2 factors. And then from there, really, it's only one more step after that. So that now you've gone from having 3 terms to having 4 terms, because you've taken out the b term and replaced it with 2 numbers. And because you have 4 terms now, then you can do factor by grouping. Okay, and you may say, well, you've got one more extra step that factor by grouping doesn't. Well, it is, but when you do factor by grouping, that 4th step, you do double the work, so they kind of even their way out on this thing. Okay, now, and depending on who you had and how you go through this one, most everybody calls this, when you're doing the quadratics with a is not equal to 1, almost everybody will tell you that this is the AC method. Because you start off doing a times c, so everybody calls it the AC method. Now, again, how you get there and what you do with it from different places, it's all a little different, but almost everybody calls this the AC method. But there's 3 or 4, 5 different ways you can do this thing and come up with the same answer. So it just kind of depends on how you want to go here. Okay, so let's give you a problem, and we'll show you both ways that you can do one of these problems. And honestly, I don't care how you get the answer. As long as you find one way that works for you and it sticks, then I'm good with it. I don't care if you've got something different that you've done before. Just let me know, and we can talk about it, and make sure that you kind of know what's going on. Okay, so we're going to go 2x squared plus 13x plus 15. And we'll start all positive on the first couple ones that we'll do, and then we'll throw a negative in there. Okay, now, and if you go back to what we were doing last time with the factoring in sections 1 and 2, you always look for a greatest common factor. So even in these, you would go back and look for a greatest common factor, but 2 is even, 13 and 15 are odd, so there's not a number that you can pull out that would divide in everything, so we don't have to worry about that. So first step we'll do is we're going to do 2 times 15, and that's a positive 30, and that's the factors that we're going to look for. Okay, and because you're multiplying numbers, usually the numbers are a little bit bigger when you have to start factoring these off, so you're going to have a bigger list of numbers in most cases when you go through on these. Okay, so listen to all the factors of 30, 1 and 30, 2 and 15, 3 and 10, 5 and 6. And we want the sum to equal positive 13. Okay, again, the good news is they're all positive, makes it a little bit easier, so even down here, all these numbers would be positive. And we just have to find the pair that's going to add up to 13. So that's the 3 and the 10. Okay, now I'm going to go ahead and show you the bottoms-up method first. This is what we teach at Sparkman on this part. So what we do is we tell people, all right, that's x plus 3 and x plus 10. All right, and if you just check the numbers real quick, if you went back and did the full method just on the last part, you've got 3 times 10, which is going to have to be 30. This number is 15. So right off the bat, we know that those things are too big. So to even this thing back out, because we multiplied by 2 in the beginning, we're going to go back and divide everything by 2. Okay, 3 over 2. Now, this part we won't simplify, so we'll come back to this one. So that leaves this one, 10 divided by 2 is 5. 3 over 2 won't simplify. So here's where the bottom up comes in. We're just going to take this 2 and pull it up in front of the x. And make it 2x plus 3. And that'll be the answer that we're looking for. And that way, if you did go back and do the full method to check it, you've got 2x times x, which is the 2x squared. You've got 3 times 5 for 15. And now all the numbers match up for what we're doing. Back here for this part, 2 divided by 2, the numbers just didn't match up because x times x would have just been x squared, and the 2 is missing. So that's one option you can do. Okay, now this is the bottoms up method over here. And again, everybody calls it something different. But that's kind of the bottoms up method. Here's what we're going to do down here for this part. This is where we'll go more for what Alex would probably have you do. So this would be more the Alex version. This is where they throw in the factor by grouping. What it says to do is, all right, if we've got 3 plus 10, that is 13. So we're going to take out this 13 and replace it with 3 plus 10. So we had 2x squared plus 13x plus 15. And we're going to take the 13x out and then break it up with 3x plus 10x. Okay. Now, and once you're here, you've got 4 terms. You have to do factor by grouping. So then you can just group the first 2 together, and then group the last 2 together, and then you're always going to go back and make sure that you got a plus sign in the middle. I know we had one here, but just in case that's a negative, still go back and put a plus in between them. Okay, now, factor by grouping. You've got the 2 groups gone for the first 2, you've got the last 2 in the group. Now you're going to take out the greatest common factor here. 2 and 3 don't have anything in common other than 1, but you do have x squared and x, so you can take out an x value. So they'll give you 2x plus 3. 10 and 15, both positive. You can divide them both by 5. Also leave you with a 2x plus 3. And again, it checks because if those 2 things are the same, we did the factoring correctly. If they're different, then we did something wrong. Okay, and then the last thing from there is whatever we have out front goes into 1 parentheses. And the 2x minus 3 will stay in parentheses back here. Okay, now, which one you want to do doesn't matter to me. Because some people learn how to do it with factor by grouping. Some people may have done something similar to this one. And really, it's the same thing. It's just a little different version than what somebody else does with something like that. Okay, so let's get you another one of those, and just so we can kind of practice. And we'll do another one without any negatives, and then we'll start throwing some negatives in. Okay, so let's go 3y squared plus 14y plus 15. Okay, now in any factoring we do, even with this part, you still want to check and see if there's some number you could divide out, because if this number had been maybe a 6 in the middle, you could divide all the terms by 3 and got this down to y squared, and then you could do the shortcut. But in this case, the 3 doesn't factor out because there is no greatest common factor. So this one, you're going to have to do the AC method. Okay, so we'll go 3 times 15 for 45. And that's the factors that we have to figure out here. Okay, now it seems like there would be a lot for 45, but there's really only 3. It's 1 and 45, it's 3 and 15, or it's 5 and 9. And we need the sum to be a positive 14. Okay, and again, the good thing on this one is they're all positive, so we don't have to worry about any signs and where they're going to be. Add 14, it's got to be 5 and 9. Okay, now again, if they talk about without, it's more than likely they're going to go with factor by grouping because it's a little bit easier to explain that you'll take out the 14, replace it with 5 and 9, do factor by grouping, which is going to work. But for what we're going to do, we're going to go bottoms up on this thing. We're going to do y plus 5 and y plus 9. And again, because these numbers are too big, because if you do 5 times 9, that's 45. We've got to go back now and take all these numbers we've got here and divide by 3 because we multiplied by 3 in the beginning. Okay, this simplifies because 9 divided by 3 is 3. Pull the 3 up, and that's 3y plus 5. And to me, once I saw this one, I realized, okay, there's extra steps in here, but those steps go 5 times faster than factor by grouping was. Because if we were doing factor by grouping, we'd still be writing the problem down. And then this one, we're done. The other good thing is that when we start solving these equations a little bit later, once you take these equations here, you've got the answers in front of you, and you don't have to do the whole factor by grouping. So to me, this is just a faster option to get to the answer because it just goes a little bit faster once you get the hang of it. Okay, let's give you one with a negative. So we'll go 2x squared minus 7x plus 15. Oh, I'm sorry. Make that 5. And we'll go. Well, 15 will be okay. Okay, so again, first step is we're going to do 2 times 15. Wait, hang on. Change that positive to a negative. My bad. Okay, I knew something was wrong when I looked at it. Okay, so we're going to do 2 times negative 15. So that is a negative 30, and that's what we need to find the factors of. And we want the sum to equal a negative 7. Okay, and again, just go through the list. Not near as many numbers as you think. And most of the factors that you do, they shouldn't be, you shouldn't have to worry about 15 or 20 of these. Usually it's 4 or 5, maybe 6 factors you might have to go through. The big thing on this one, again, is that your B term is negative. That number still has to go, or the sign has to go with the bigger factor. And then if you do a negative by negative, it makes the other number positive. All right, and to get negative 7, that's the 3 and the 10. Okay, but again, the numbers are still too big because we did 3 times 10. That would make that last number 30. And because we multiplied by 2 in the beginning, we're going to go back to even this thing out and divide by 2. Okay, again, this one simplifies. Make x minus 5. This one doesn't simplify, so we'll pull a 2 up in front of the x and make it 2x plus 3. Okay, now, and that actually was a mix of 2 objectives in numbers 1 and 2. Let's do one more of those, and then we'll call this objective number 2, because there's really not a big difference between objective number 1 and objective number 2 when we're in 6.3. I think the only thing that might be a little bit different is the numbers may be just a little bit bigger. Shouldn't be like huge bigger. But the numbers, when you do the A times C, the numbers might be just a little bit bigger when you go through this. Okay, so if you multiply 10 times 5, that is a positive 50. So that is the factors that we're looking for. And we want the sum to be a negative 27. Okay, and again, another one of those problems where when you go through 50, you think there's going to be a lot of numbers, but there's really not. It's 1 times 50, it's 2 times 25, or it's 5 times 10. Okay, the B term is negative, so the bigger number needs to be negative. When we do a positive divide by negative, it makes the other number also a negative. So I get negative 27, that's going to be the negative 2, and the negative 25. Okay. I guess this is really the big difference. When we go back and divide the numbers by 10 to make everything work out. This one doesn't come out to be a whole number. So we simplify it down, so that's x minus, you can divide them both by 5 and make it 5 over 2. This one you can divide them both by 2 and make it 1/5. So for this one, both of them have a fraction, so in this case you're going to pull both numbers up. So this one we pull the 5 in front of the x to make it 5x minus 1. This one we'll pull the 2 in front of the x and make it 2x minus 5. And if you need a quick check, just something if you want to make sure that all the numbers matched up, just go back and do, instead of doing the full method, if you just want to multiply the first two terms, because you've got 5x times 2x, that's 10x squared, and do the last term, 1 times 5 is 5. If you just do those two parts, then it should be just a really quick check. Now, you could go back and do the O and the I terms, but probably about 90% chance good that if the first two terms come out to be 10 and the last two terms come out to be 5, you're pretty well safe that that's going to be the answer that you're looking for. Okay, so all the other problems we had done back here, one of the numbers would come out to be a whole number, the other part was a fraction. For this one, objective 2, really the biggest difference is the numbers may get a little bit bigger, but there's a good chance that both of these are going to have fractions that you then got to go back and pull up there. But it's still the same thing. If it simplifies, that's great. If it doesn't, just pull the numbers up in front and you've got everything. Okay, and then the third objective that we got in 6.3 for objective 3 is instead of just having one variable, you're going to have two variables. So let's go with 2x squared plus 17xy plus 35y squared. Okay, now and honestly for this one, best thing to do is just ignore that second variable. That for this one, just go ahead and think about it being 2x squared plus 17x plus 35. We'll bring the y's back in at the end, but that's for this one. You can just ignore the extra y's for a second and just think about it this way. Okay, you're still gonna do the same thing. It's still 2 times 35. So that's positive 70, and that's what the factors are that we need to find. And we want the sum to equal positive 17. One and 70, 2 and 35, 5 and 14, or 7 and 10. I think that's it. Okay. Again, B term is positive, so that, and again, these are all positive, so the good news on that one is all these terms have to be positive. Here that adds up to 17, that's the 7 and the 10. So x plus 7, x plus 10, we multiplied by 2 in the beginning, so for these we're going to go back and divide by 2. So 10 divided by 2 is 5 on this one. 7 over 2 won't simplify. So for that one, you can pull the bottom number up in front of the x to make it 2x plus 7. Okay, now, and the only difference we do with this second variable that's here, when you get your answer, is you just go back and tack a y on the second numbers. So it's 2x plus 7y, and then x plus 5y. So you still set it up, still do the exact same thing, just the difference is, again, instead of just being 2x plus 7 and x plus 5, if there's a second variable, just go back and put the variable on those numbers. Works out the exact same way.